Tesla is no longer a car manufacturer. It's a hardcore tech company striving to contribute to the development of super intelligent artificial intelligence, universal humanoid robots, and a bright future with abundance for all. That's what Elon Musk tried to convey to everyone at the Tesla AI Day, where he showed his humanoid robot Optimus. To find out what did and didn't work for Elon Musk's company over the past year, watch today's video. Tesla AI Day opened with a demonstration of a prototype of the Optimus robot, which gave reason to speak out with absolutely all of Elon Musk's critics. In part, it's hard to disagree with them. The robot's far from the beautiful glossy rendering we saw last year, and as of today, it really is 1,000 light years away from what Boston Dynamics is doing, at least in terms of dynamics. And of course, it continues to be disconcerting that a lot of experienced humanoid robot developers around the world are embarrassed to say that their robots could ever be sent to the grocery store to get groceries or to mow your lawn. Also, Musk never realized the number of his ambitious projects. So, how do you feel about the robot prototype Musk presented and what it's actually looking like in real life? Speaking of Tesla, check out our friend Mike over at the YouTube channel EV All Day, where Mike covers the latest developments in electric vehicles, from all things Tesla and electric cars, trucks and SUVs, to eVTOLs and everything in between. Go give his channel some love. And while you're there, subscribe to Mike's channel and write in the comments, "Hello from Pro Robots." And now, let's get back to Tesla. At the very beginning of the event, a robot called Bumble C, which was created by Tesla developers, took the stage. It was created by Tesla developers from available components in 6 to 8 months. And interestingly, during the Tesla AI Day event, for the first time, the robot walked on its own without any support or insurance. It moved slowly, it danced a little for the audience, and then turned around and left. Elon Musk said that the robot can do much more, and the company decided to avoid embarrassment on stage, as it was with the broken glass of the Cybertruck, so the remaining abilities were demonstrated on screen. The video showed him carrying boxes, watering flowers from a watering can, and carrying parts at the Tesla factory in Fremont. In the video, you could see not only the robot's movements, but also how it sees and perceives the world around it. The robot has hardware-level safety gestures that are important to protect, both on the robot and the people around it. But Bumble C is only a prototype model for training. A close-to-production version of the Optimus robot was unveiled on stage a little bit later. The fully assembled but little-functioning robot was mounted on a stand, although it could wave its arms and legs. Musk noted that the company did not have time to prepare the robot for presentation, and it will probably be able to walk and act on the level of Bumble C in just a few weeks. With that said, in 5 years, Optimus' capabilities will be incredible, and in 10 years, it will be mind-blowing. Musk is a known optimist, but let's still break down in detail what the Tesla bot is right now. We know that the robot weighs 73 kilograms and it's powered by a 2.3 kilowatt-hour Tesla battery running on a Tesla SoC chipset, which has Wi-Fi and LTE connectivity. Interestingly, the battery pack has all 3 electronics integrated into a single printed circuit board inside the unit. The power consumption of the robot is 100 watts while sitting and 500 watts while walking. The battery at this power consumption should be enough for an entire day's work. Engineers designed the robot so that the mobility in the joints and arms, legs and hands was as close to a human as possible. For example, the robot's hands will replicate the structure of a human hand with an opposable thumb. The fingers are driven by metal tendons, which are both flexible and strong. The robot has the ability to perform a wide range of grasping heavy objects as well as delicately picking up something small and thin. Interestingly, just like Boston Dynamics' Atlas robot, the Tesla Optimus uses its arms to maintain balance while walking. Of course, we were surprised by the robot's linear actuators, which can lift a grand piano weighing a half-ton. With these type of actuators, Optimus can lift weights as well as a human, and maybe even more, and this is a real breakthrough for humanoid robots. With all of that said, the robot's design is somewhat limited by standardization. The developers created designs for each joint and then looked for common areas in each joint to be limited to the using only 6 different actuators. At the presentation, it was emphasized that keeping in mind the need for low-cost mass production, the engineers tried to reduce the number of parts and energy consumption in each element of the robot's design. And as a result, the robot today has 28 structural actuators. The number of degrees of freedom in the arms is not yet clear. For example, 27 degrees of freedom was stated, but one of the slides lists that number as an 11. In the whole body of the robot, however, there's 200 degrees or more of freedom that are claimed. The Tesla autopilot software was transferred from cars to bots and reconfigured to work in the new body and environment. As input, the system took videos of people performing real-world tasks such as lifting boxes, and then, using inverse kinematics, it tried to get the Optimus robot to repeat those movements. In parallel, online motion adaptation was applied so that the robot could perform actions smoothly with an unstructured environment in mind. The developers noted that eventually the robot would use hardware from the autopilot and software for the humanoid platform. The Tesla computer on board the robot will do everything the human brain does, processing data and making discrete decisions based on signals from multiple sensor inputs, as well as communicating wirelessly. Optimus uses computer vision, taking data from multiple cameras, including a fisheye camera, which it understands the world based on three-dimensional presence, a panoptic segmentation, and YUV color modeling. And it uses these techniques as general view rendering, volume depth rendering, visual navigation, and others. Optimus has hardware-level safety features to protect both the robot and people around it. Tesla already had an emergency software for cars, and the company applied the same to this robot. In the case of a car, the software simulates a collision, and in the case of the robot, it's a simulated fall. As a result, when the robot falls, it's so protected from damage that it can simply stand back up, shake itself off, and continue doing work. In the future, according to Musk, the main difference between Optimus and other humanoid robots will be artificial intelligence, allowing it to navigate the world on its own, as well as large-scale production, which should reduce the cost of the robot to literally $20,000. To make the robot useful as quickly as possible, engineers will try to adapt it to real-world tasks in Tesla factories as soon as possible. Musk's timeline for starting production is, as always, optimistic and unrealistic. He hopes to start producing robots as early as next year. Well, we all remember the promises of an autonomous car in 2017 and the release of the Cybertruck in 2021, so for now, we can safely add 5 years to this date. As always, Musk is generous with his promises, and he doesn't forget about humor. For example, he assures us that Optimus will get conversational capabilities as well as plenty of funny lines, including a cat girl. "We always have to be careful not to go in the way of the Terminator," Musk added. "We want Optimus to be safe." All in all, the natural beauty of the robot presented is a far cry from the clever universal humanoids seen today, except in a sci-fi movie. But that's what's to be expected, given that a year or so ago has passed since the development began. And compared to the actor in the suit, Tesla has made good progress. Given that the company, like SpaceX, is where it is today, thanks to Musk's pure will, we wouldn't write Elon off as a robotics company. "It will be a fundamental transformation of civilization," Musk said of his robot, and deep down, we want to believe him, don't you? Let us know down below. To Tesla's other achievements, the disappointment of many of the company's electric car fans, the launch date for a full-fledged autopilot feature has remained unnamed. Beta testing expanded from 2,000 to 160,000 users in just a year, but remained a beta test. And while Musk is answering questions after the presentation, he said it would probably be rolled out by the end of next year, and that timeline, as it was, could be very tentative. Speaking about full self-driving's progress so far, the developers said they've expanded the training infrastructure by 40 to 60%, which has greatly improved the pace of development. The company has trained more than 75,000 neural network models in 1 year, and that means about one model is tested and verified every 8 minutes. Going into a little more detail about the infrastructure, Tesla notes that it maintains a cache of more than 14,000 GPUs for the training. Nearly 500,000 videos pass through the system each day, and so far nearly 1.5 billion frames have been used to train the autonomous driving system. The entire training dataset now contains nearly 5 million clips. But in addition to videos, the company is generating a huge amount of data and simulations, reconstructing real-world streets and intersections such as San Francisco. Tesla has also switched to an advanced dataset labeling system to train the FSD system. It's claimed that 5 million hours of manual labeling have been reduced to 12 hours of automated clustering. FSD experts describe how, in certain situations, the camera image is not unambiguous, and the auto software uses additional frames to reconstruct the scene. And as a result, the company hopes to create fully autonomous cars without adding new equipment. The company's engineers also spoke about the progress of Tesla's own supercomputer Dojo. Thus, the first cluster of the Dojo Exapod supercomputer will be completed by the first quarter of 2023. The company plans to build a total of 7 such clusters in Palo Alto. According to the company, the system with 10 Dojo Exapod cabinets will break the 1 exaflops milestone. The increase in computing power should accelerate the creation of both robotic and humanoid robots. Tesla's currently assembling one tile per day with 25 Dojo chips on each. Incidentally, when asked if Tesla was going to sell Dojo, Musk said the company would rather provide access to the supercomputer's computing power as a service. He described it as a service you can use on the internet where you can train your models much faster and for less money. How do you rate Tesla's progress over the past year? Let us know in the comments. And while you're here, subscribe to our channel, like this video, and don't miss any new episodes from the world of high tech.